We're talking about equilateral and isosceles triangles. And in questions 1 through 10, find the value of x. For equilateral triangle KRT, solve for the value of x. So it tells us it's an equilateral triangle. And so I want to sketch my image. And I'm going to make all of my sides 1 inch. So the base there is 1 inch. Be able to sneak it in 1 inch, and then we'll just connect this over here, and hopefully it is about 1 inch. Not quite 1 inch, but it'll be good enough for the sketch. And then we want to label all of the parts. We got KRT, so we'll put K up here, we'll put R over here, and then we'll put T over here. Now it just says find the value of x. So it gives us this extra piece of information. It says RT, the length of RT is 3x minus 5. Doesn't really matter for this particular instance. So if we remember, all of the angle measures of an equilateral triangle are 60 degrees. So it says K is 5x. And these are all congruent. And then it says T is 4x plus 12. And it doesn't give us a measurement for R, but what we know already is that they're all equal to 60, so R is equal to 60 degrees. Now we can use our triangle sum theorem, and we can solve for x. So we have 180 degrees is equal to all of the angles added together. So that is the measure of angle K, the measure of angle R, and the measure of angle T. And then we can substitute in the values that we know. So 180 is equal to all the sides added together. So we have 5x, we have 60 degrees, and we have 4x plus 12. So when we go ahead and do our math and we can combine like terms, we get 180 is equal to 5x and 4x is 9x, and 60 plus 12, that is equal to 72. And now we can take 180 and subtract 72, and we get 108. So we can subtract 72 from both sides. And then we get 108 is equal to 9x. And then we can divide by 9. And we get x is equal to 12. We did not need to know the value of RT. That didn't really help us out. We just needed to know the angles there. Next, we have angle 7 and angle 8. And again, we have the congruent marks here, so we know that this is an isosceles triangle. So we know that this base angle is congruent to base angle. And so we know that this is going to be also 2x plus 3. And then we know that this measurement right here shows that it's 90 degrees. So again, we can use the triangle sum theorem, where 180 degrees is equal to all of the angles added together. So we have 2x plus 3 2x plus 3, and 90. Then we can combine like terms. So 3 plus 90, that's 96. And 2x plus 2x, that is 4x. So then we can subtract 96. And then we get 84 is equal to 4x. And divide by 4, and we get 21 is equal to x. Here again, we have another isosceles triangle, but because of that measurement right there, we actually know that it's an equilateral triangle. Because if it's 60 and the other two angles have to be congruent as well, then they're all 60 degrees. So that tells us that all of the sides are congruent. So in this case, if all the sides are congruent and all the angles are congruent, then we know that these two sides are equal. So we can set them equal to each other. 3x plus 8 is equal to 4x minus 4. And then we can start to solve. So we're going to add 4 to both sides of the equation. 3x is equal to 3x. That's going to be plus 12. I wonder if I can put it plus 12 is equal to 4x. And then we can subtract 3x from both sides. And then we get 12 is equal to x. We have two last examples. And here we have, to start out with, we know that this is an isosceles triangle. So if this angle is x, then this angle G is also x. And then we have to figure out what angle H is up here. And we should know that this is vertical angles. That's a vertical angle. So this angle and this angle are congruent. We'll have to put 3 there because I've already used 2. So this is equal to 28 degrees. So once again, we can use the triangle sum theorem, where we say 180 degrees is equal to all of the angles added together. So then we have the measure of angle H plus the measure of angle G plus the measure of angle K. And then we can substitute our values in. So we have 28 for the measure of angle H. We have x for the measure of angle G. And then we have x for the measure of angle K. Now we can combine like terms. And we get 180 degrees is equal to 28 plus 2x. We can subtract 28 from both sides of the equal sign. And we get 152 is equal to 2x. Divide by 2, and we get 76 is equal to x. And our last example is example 10. You have a combination of triangles again. And we start off with this isosceles triangle on the left side. And so we know that it's isosceles. So our base angles are also congruent. Now, we don't have a measurement for those, and we already have an x established. So what we're going to call this one is we're going to call this one angle y. The measurement of this one is going to be y, and then the measurement of this one will also be y. So now we can use the triangle sum theorem again. We can say 180 is equal to all of the angles added together. So we have 54 plus y. And now we can combine like terms. So 180 is equal to 54 plus y plus 2y, because we have two of them. Subtract 54, and we get 126 is equal to 2y, divide by 2, and we get 63 is equal to y. Now that's not our answer because we want to solve for x. So now we have to use our linear pair because we have a linear pair right here. And what that says is if we say both of these angles added together equal 180, so 180 minus our 63 that we calculated for this angle, and that is going to be equal to our remaining angle here, which is going to be 117. Now we have another isosceles triangle. So if we know that this angle is congruent to this angle, and this angle is x, so this angle also has to be x. So we have three measurements, and again we can use our triangle sum theorem. So 180 degrees is equal to all the angles added together. So that's going to be 117 plus x plus x. Show the difference in calculation there. And we can combine like terms. So we have 180 degrees is equal to 117 plus 2x. We can subtract 117 from both sides. And then we get 63 is equal to 2x. And then we can divide both sides by 2. And then we get 31.5 is equal to x.